The Sunshield of the James Webb Space Telescope is about the size of a tennis court, like the one I'm walking on right now. But try to find the material Kapton that the Sunshield is made of that's big enough, well, you're going to be out of luck. So we've come to Huntsville, Alabama, where the folks at Mantech are building the Sunshield. So John, you are the chief process engineer for this Sunshield. Can you tell us a little bit about what Kapton is?
Yes, you have some of the materials in your hands here. Kapton starts out with this amber color. This is raw Kapton, as we'd call it. After that, the Kapton goes through a coating process where we put the aluminum metal coating on, as you can see it here, on one side. Then we process it again to have a coating on the other side. In the end, 3 layers of the Sunshield have the aluminum coating on both sides. The remaining 2 layers will have aluminum on one side with silicon coating on the back side.
You're not going to find this off the shelf, right? You can't say, hey, order some of this that's about the size of a tennis court.
Yeah, that's a real problem, because we buy it in 50-inch wide pieces, and it's got to be the size of a tennis court. So we have to put those pieces together, and we have a special process that we do that, and that's over our facility just 5 minutes from here.
So can we take a look?
Yes, let's go.
All right.
Well, what we're cutting here is individual pieces, and they will be seamed together.
There's at least 55 pieces per layer of the Sunshield.
Right, and then they will match the gold sides to each other to seam it. Now we've taken them over to the thermal spot bonding machine. The heat comes out of the tips to fuse it together, but not so much that it burns through the bottom.
So why do you use a thermal weld? You're not exactly sewing the Sunshield together in the traditional sense.
We want to maintain the strength as much as possible of the parent material, but still have it stay together. Not have glues or anything else which adds weight.
You know, now that I'm looking at it closely, it kind of looks like one of those potato chip bags, no?
Yeah, like the one I carry around in my pocket.
How convenient.
Yeah, well, I thought that y'all maybe have had some Doritos, but you always looked on the inside, you noticed how that shiny surface?
Yeah.
Well, that's to protect the insides, from contamination. Because this is a plastic material, it can't meet the requirements of outer space environments. Kapton has the aluminum coating on it. It's made specifically for space environments. We've been using it for several decades.
Okay.
You grab that end, and I'll grab this end, and we'll see if we can make it.
All right. Oh, wow.
So now you have a feel for how much it takes. That's pretty strong.
Yeah.
That's 1/1000th of an inch thick.
Ooh, okay.
So that's thinner than paper.
Right. All right.
So now the machine's set up, it's ready to go. There's a certain rate that it's pulling it, and it's steady.
Now you don't expect to see those kinds of forces on the Sunshield.
No, we're going...
You're going way
beyond what it's going to be stretched at. Yes.
Okay.
This is good. This is a great seam. Look at this. 31, 30, almost 32 pounds.
It far exceeds what JWST needs.
This was great.
Great.
Perfect.
Well, thanks, John, for showing us how you guys make the layers of the Sunshield so large.
Sure, there's no problem.
But putting together the Sunshield is much more than just making it the right size. We'll talk more about what else needs to be done on another episode of Behind the Web.